All attendees are in listen-only mode.
Good morning, everybody. Welcome to Hilti Philippines webinar. As we all know, we are currently having a major crisis, which is the COVID-19. And with that, we are now under enhanced community quarantine. As you know, today we will be joining by another colleague that is remotely located in Manila. So before I start, our today's discussion is about Profis Engineering Advanced Baseplate Next Generation Anchor Design Software. It's a pleasure to have you today and we thank you for your attendance. By the way, I am Engineer Joni A. Cruz, Technical Marketing Manager of Hilti Philippines. For our today's session, again, another colleague will be joining us. He is a licensed civil engineer, graduated from Technological University of the Philippines, Taguig. He was previously connected on one of the top private structural consultancy firm in the country, handling structural analysis and evaluation of existing structures, and now one of Hilti's specification engineer, handling structural trade, none other than Engineer Richmond Olaya. Before we start, few reminders and some housekeeping rules. You should now have on your screen a slide showing some of our housekeeping reminders. On the right-hand side of your screen, you will see a control panel for the webinar's interface. Now let's go quickly over the functions of its interface. On the left-hand side of your control panel, you should see some series of buttons. Top orange arrow allows you to hide and show the control panel. The rectangular icon allows you to view in full screen or in window mode. Now, the speech bubble will appear when there are messages from Hilti. Further down is the question box. If you cannot see it, please click the little arrow next to the word question. And with this, you can type in your question in the box and we will respond during the session. For today's session, we will also be asking few poll questions to make it more interactive, as well as to confirm the understanding of the topic being discussed. Now, in previous webinars, we are aware of the issues with sound during broadcast. One thing you may consider is your available bandwidth, as this can affect the connection quality. So please close all other internet-based applications, such as Outlook or Internet Explorer, that you may have open. Lastly, at the end of the webinar, a survey will be launched. When you close the session, we kindly request that you take a few minutes of your time to send us your feedback for our future improvements. Also, just to note that the webinar session will be recorded for quality and coaching purposes. Now, to start the presentation, and without further ado, I turn you over to Engineer Richmond Alaya.
Thank you, Joni. Good morning, everyone. Welcome to Hilti's webinar on Profis Engineering, the next generation anchor design software. It's a pleasure to have your company today, and thank you for your attendance. By the way, my name is Richmond Olaya, Specifications Engineer here at Hilti Philippines. And as your partner in the industry, we are going to help you by providing a software called Profis Engineering. This can easily help you to hasten the computation for the capacity of the whole anchoring fastening assembly. So before I go to the main topic, let me give you a brief introduction about our company and what we strive to achieve. So you're probably familiar with Hilti as a global company that develops innovative premium anchoring products. So as we continue to evolve as company, we are focusing more of our time and energy developing solutions that lie outside of the realm of products, emphasizing our efforts on bringing world-class software and services. So our corporate headquarters and parent plant is located at Liechtenstein, a country between Germany and Austria. And just the size of Quezon City. Also, when talking about innovation, Hilti has a long-standing reputation as a technical expert and leader in anchoring technology. So we continuously invest 6% of our annual revenue into research and development so that our anchoring products address common concerns in the construction industry and perform at the highest levels. So we have worked hard to innovate our anchoring product, and so our customers can understand the value that we bring to each fastening point. So we want you to get what you specify. So which is why Hilti cares that your design of anchor is accurate, simple to execute, and code compliant. And today, we will now go to our software recommendation to help you in your computation. So the presentation for today will be as follows. We will start with an overview of the parts of anchoring assembly. Then we will be discussing the current situation and challenges or pain points that we have found with regards to anchor connection design. Then we will give you an overview on how Profis Engineering can help you solve these challenges. We will also go on a live demonstration on how Profis Engineering works. And finally, before we wrap up, we will open the floor and cover some questions after the presentation. So now, let's have a quick review of the basic anchoring assembly. When we talk about anchors, we do not only discuss the fastener or the anchor itself. So let's be clear about the definition. So an anchor assembly consists of the fasten part of the fixture. Usually these are your base plates, ledger angles, handle support plates, which is connected to a base material, which is usually concrete by an anchor, whether cast in or post installed anchors. Then the fasten element, which are usually structural steel shapes such as IB or structural channels, and also additional connection details such as stiffeners, plates, and weld. So similar concept with composite construction, the design for an anchoring assembly should be able to work as a single unit or an assembly performance. So now, before we proceed for the next section of the presentation, let's first do our first poll of the day. So as the polling windows opens up, so how do you design steel to concrete connections today? By hand calculations? Is it by custom Excel spreadsheet or anchor design software? Using finite element analysis, FEM, or all of the above? So we will give you a couple of seconds to cast in your answers. So 5, 4, 3, 2, and 1. So now let's have a look at the answers. So majority of you answers custom Excel spreadsheets within your company and also using Anchor design softwares. And some are using more on hand calculations. So results is same as what we have done with our marketing sensing. So we will now look at these challenges or pain points that we have to address today. So some of the pain points are as follows. So currently, designers experience different situations in relation to anchor connection design. So first example is the interruptive workflow. So you will be using other software or approach in checking for the design of your structure, different method for or software in designing your base plate, using other software in designing your connection, and even different methodology when designing anchor or fastening system. So we also have rigid base plate myth. So as the assumption that the base plate would always be stiff enough and would not deflect during the life of the connection. And last is the design transparency, so which will be used for verification and calculation references. So basically, these situations are also the typical pain points that designers like you tend to encounter. So first pain point of a designer was there are different approaches that can be used to do a base plate and connection design. So from the past experiences, we found that these different approaches range in both the level of detail and complexity in terms of base plate design. So due to different approach, the time taken to do each check and some factors like additional steel plate, weld check, anchor geometry, and capacity checks are often come into consideration when determining which approach you would like to use. So at one end, we have hand calculations, which is simple check to give a quick idea of the base plate yielding. So this often involves making some conservative assumptions and simplifications. Thus, this ultimately the quickest check. So next, we have the design guides. So these are publications by official bodies, such as American Institute of Steel Construction, ACIA, and NSCP for the Philippines. So these go into more depth as they are often based on a literature or research. and often use yield line or linear elastic analysis. So these do, however, to up only a finite set of standard arrangements, which we will be discussing in the following slides. So these offer a series of design checks, which boil down to a set of equations to again give a simple yes or no set of design checks for the connection. So following this, we have our connection software or custom spreadsheets. So these are often just implementation of the previous two methods to speed up the process. So we often found that these three are the most common approaches among designers as they can quickly provide a solution for most standard connection. So finally, we have a finite element analysis. So this gives the greatest level of detail and can model nonlinear behavior of the connection. So however, it takes a much greater amount of time to generate the models. So specify the appropriate boundary conditions and ultimately validate the model. So another pain point is within the connection design process. So typically, there are multiple touch points involved to do the connection design. So here is a rough look at what the design process might look like for a single connection. So from a superstructure design, which is often done using a structural analysis software, we have to transfer our loads for a connection design. So now at our worst, we could have at four different touch points to design our base plate, design our weld, stiffeners, and anchors. So although there are some software that may design two or three of these components, ultimately, there is always a disconnect between the anchor design software and other connection components. So on top of this, there is a manual transfer of data between each of these touch points, which involves a redesign of geometry and loads, which could lead to an erroneous input. So ultimately, the combination of these things results in much greater amount of time taken to design a single connection. And we think we can do better than this. So lastly is the rigid baseplate myth. So now, the hot topic of anchor baseplate world is the rigid baseplate. So let us deep dive further into this myth and what are implications of using rigid baseplate. So all anchor design software currently calculates load distribution and anchor resistance based on a rigid baseplate assumption. So this only means that the baseplate is assumed not to deform under tension, shear, or bending. So resulting in a linear strain distribution through the anchors. So this is commonly known as the elastic theory and is used to simplify the connection and calculation of the loads on the anchors. So importantly, this elastic theory is used for the derivation of many concrete failure modes to do with the concrete capacity method, so which majority of anchor codes are based on. So the significance in this is that a rigid base plate is also a requirement of ACI and European guidelines and most post-installed anchoring standards. So the code that the fixture must be sufficiently rigid such that the linear strain distribution remains valid and the deformation is negligible. So this complicates things a bit, as when we are doing market sensing, there was a large interest in being able to design both rigid and non-rigid connections. So however, we did not want to provide a software that design flexible base plates, as it would be putting the design outside the scope of the codes. So this is something we want to address in Profis engineering. Now, let's have a look at some of the differences between rigid and flexible plates. So for example, we have an anchor connection to resist a 10 kilonewton tension force. So for rigid base plate assumption, with no deformation of base plate was assumed, there will be no additional tension force that the anchor will resist. So now this is different with the analysis of the fastening, considering the base plate deformation. The consideration of prying force induced under the base plate will automatically result to increase in anchor loads. So many designers and software take this into account by providing approximate prying safety factors. So however, this safety factor is often assumed to reduce the pull-out capacity. Now, when we consider the behavior of plate under tension and compression on the next slide, So for anchor connection under tension, prying force induced under the base plate and on the corner of the plate results to additional tension force to be resisted by the anchor. So as for the compression case, the concentration is under the profile, resulting to additional bearing stress on the concrete member. Then lastly, for the bending case, so with the non-rigid consideration, we can see that there is a combination of prying force generated at the tension interface of the plate, and there is a reduction on the lower arm and the tension and compression region of the connection. So thus, both will result to increase in anchor forces. Now, if we will start looking at the behavior of the connection, we can no longer consist the anchor and the plate alone. So the behavior is affected by all the components of the connection, such as the profile, stiffeners, weld, plate, anchor, and also the base material. So next slide is an interesting sensitivity study as we deviate from a rigid base plate as we can get much different anchor loads in the plate. So this graph represents our base plate. As our base plate gets thinner, we can get much larger increase in anchor forces for a given moment. So this highlights the discrepancy between what Profis anchor or any rigid base plate assumption software might be taken into account and might actually be happening within your connection. So overall, as I mentioned, there are multiple factors that could influence the rigidity of the connection. So there is no black or white answer to this problem. So all the factors were seen in this slide, such as base plate size, stiffeners, base plate thickness, anchors, and so on. So with that in mind, so what will happen if the base plate deformation is not considered in anchor connection design? So worst case is we can get some situation like this, where we have a plate experiencing large deformation, which results to connection failure. And failure of critical connection can put human life at risk. So which is something we all want to avoid. So with that in mind, let's take our second poll of the day. And the poll question is coming up to your screen right now. So how can I design the base plate so that the behavior be similar to that of a rigid plate? Increase the base plate thickness, change the steel profile, base plate size and dimension, rearrange and adjust the anchor layout or anchor geometry, or use different anchor. So we will give you a couple of seconds to cast in your answers. So I will give you at least 10 seconds. So 5, 4, 3, 2, and 1. So let's have a look at the answer. So majority answers increase the base plate thickness. Some answers change the design, profile of base plate, size and dimension, rearrange the anchor layout and use different anchor. So all the answers are valid as you will see in the live demonstration later. So now we will be moving on the discussion of Profis engineering. So just to recap, there are challenges or pain points we want to address in anchor connection design. So first is the workflow integrations, wherein there are a lot of approaches when it comes to anchor connection designs, design of your structure, design of your base plate. So second is the multiple touch points for designing a single connection. So and finally, the inability to quantify the effects of non-rigid plate or plate deformation and determine how close to rigid our base plate is. So the question becomes then, so is there a better way of designing connections? So for Hilti, yes, there is. So, Hilti developed Profis Engineering as replacement to our industry-leading anchor design software, the Profis Anchor. So with Profis Engineering, we have streamlined the process by offering the design of the entire connection within a single platform. So removing the need to jump between the different software and manually transfer your loads. So in addition, we have addressed the whole end-to-end process by integrating with key design software and detailing softwares to further automate this process. So Profis Engineering will replace our leading Anchor design software, Profis Anchor. So some of the changes will be discussed during our live demonstration. So and with Profis Engineering Premium, which offer 3 licenses options, that integrates the key design software to enhance the end-to-end workflow of your Anchor design process. So Profis Engineering Premium still has the state-of-art on Anchor design, but for the premium version, it can on it can now integrate with user-relevant software, designing softwares such as ETABS, STAAD, and Sub 2000, and now it can now be able to do a base plate analysis using component-based finite element method or CBFPM. So with Profis Engineering, we plan to streamline the process so that our engineers who use a structural engineering software to design the structure can automatically import their load combinations into Profis Engineering. So by using a plugin. And with the Profis Engineering, we will do the full connection design. So furthermore, once the design is done, the parameters and anchor geometry can be exported to Tekla and other BIM or CAD detailing software. So for the integration part, we can look at the sample on the next slide. So we will do a sample on a STAAD Pro Connect. So for importing loads, so first of all, we're using the STAAD Pro Connect. So I need to log in your Profis Engineering platform using this account. Then we will now go to our structural software. So in this case, STAAD Pro Connect. Then go to the Run tab to calculate the support load reactions of the superstructure. So there. So you may now go into the tab where you will see the different load reactions and load combinations that you will use with the design of your connection. So you may select the governing load that you will use with your design of connection. So we will at least select three governing load combinations. Then you may now go directly into Profis Engineering platform. So click on the design, then the load import for STAAD Pro. Then it will be automatically show you the selected load combination. Then you can now design your fastening connection using the preferred loadings. So here. So in the result tab, you will see the utilization for each load combination and go with the design of the to optimize the connection. So you may select the governing or all load combinations to see the utilization. So for the export, furthermore, when you are done with the design, you may export the geometry, stiffener plate, anchor, etc. for the specific connection. So if you are using Tekla structures, you may download the plugin into the link provided into this slide. So also, what happens if you are not using Tekla as your detailing software? So the beauty is that we can also export CAD files, BIM files to various formats. So you may export geometry with other detailing software like AutoCAD or Revit in the future. So if you want to learn more about the integration of Profis Engineering to other structural software or detailing software, you may refer to our on-demand webinar at www.ask.hilti.com.sg for that discussion. Now, going back to the design of full connection in Profis Engineering, the offering we have implemented in Profis Engineering includes the following. So first, the same anchor design with rigid baseplate assumption according to ACI or Eurocode. So secondly, we have include a finite element analysis module using what we call component-based finite element method, so which can complete a full nonlinear analysis of a realistic baseplate behavior. So the advanced baseplate module in Profis Engineering enables a holistic design of the anchors and baseplate as well as the verification of the actual stiffness of the material, which has a significant influence on the fastening capacity. So users can choose whether they want to do the design with the full advanced baseplate analysis considering the realistic stiffness of the baseplate or with the assumption of a rigid baseplate as done in the past by selecting the calculation process accordingly. So the full advanced baseplate design is done with CBFEM procedure. So each component is realistically simulated. Your concrete, stiffener plate, base plate, anchor, steel, and also weld check. So as mentioned, in order to model the realistic nonlinear behavior of our connections, we use component-based finite element method. So CBFEM individually model each connection components and connects them all together in the global model. So we model the concrete as compression springs. So the steel is modeled with 2D quad and tri-shell elements with a bilinear stress strain curve. So now these elements are automatically meshed and automatically refined around the anchor nodes to a refinement level optimized to achieve a convergent solution. So this is why the model can be calculated so quickly, as you will hopefully see in the demo of the software later. So and the anchor themselves are modeled as bilinear tension springs. So the stiffness of the anchor is unique on a per anchor basis and has been determined through hundreds of Hilti's own internal testing to determine this critical data, as the anchor stiffness have a significant impact on the overall design. So now let's get into more details about CBFEM. So a higher precision of the calculation can be reached with a thinner mesh, same as what you are doing in your other structural software with mesh. So, but the finer the mesh, the longer the calculation time, which exponentially increases by the mesh density. So by default, Profis implements a plastic strain limit of 5%, which is based on guidelines from Eurocode. So if we look at this example, we have a connection with an increasing moment. So in the first section, we are still in the elastic region. So our max stress is less than the yield. So increasing the load, we start to see some local yielding around the anchors and the profile corners. So the plastic strain is only at 0.1%. So increasing the loading even further, we see that much of more of the plate is in the plastic region, but we are still only at 0.4%. So increasing even more, and we see that the plate is considered overloaded. So a large majority of the plate is plastic. But more important is that the plastic strain has reached at a much more rapid rate. So as the strain is greater than 5%, the software has determined the plate to be failed. So as a user, you have the option to increase or decrease this limit, change the thickness of the plate, but this is ultimately upon your engineering judgment. So also, verification of weld is according to Eurocode 1, the simplified verification. So welds are modeled with an ideal elastic plastic behavior. So if a specific weld design is not necessary, so you can select butt weld or complete joint penetration. So a butt weld doesn't need to be verified according to Eurocode. So reason is that its bearing capacity can be set identical with the one of the weaker connected elements. So weld has the same thickness, but it always done by the superior material. So if the weld shall be optimized, you can select the fillet welds. So the strain displacement curve of fillet weld follow an ideal elastic plastic behavior according to EN 1993-1-1 at part 5.8. So a load redistribution along the weld is admitted. So a plastic deformation is admitted up to the limit of 5% also for weld. So Profis Engineering follow design approaches for different regional design guidelines. So as for the Philippines, for steel guidelines, we follow AISC, Steel Libraries American Standards. For conducting an anchor design, we use ACI references, ACI Chapter 17, and NSCP 2015 7th edition, Chapter 4, Section 417. So, okay. So what does the design process looks like now in Profis Engineering? So the first but critical step before we do any anchor design checks is we need to assess the rigidity of our base plate. So this is because code still ultimately assumes a rigid base plate. So this does not mean we cannot design flexible base plate. So however, as designers, we need to be aware that some of the calculations using rigid base plate before will no longer be valid with non-rigid base plate assumptions due to the additional anchor force. So now we will be going now to our live demo. So for our live demo, we will be making a design connection of W6 by 9 A36 steel connected to to an existing foundation with 700 thickness of concrete base material. So the size of base plate is 300 by 300 by 10 thick. So welds 3 for flange. Concrete strength is 5,000. So based from our discussion yesterday, so we will be using crack concrete condition. So anchors will be using a Hilti product. So HIT RE500 V3, which is an adhesive type of anchors, plus has U 8.8 rad. 8.8 is the capacity of rad. So 4 has U 8.8 rad. So the spacing between anchors is 190. So edge distance or the center of the anchor to edge of base plate is 55. So the design load is 50 tension and 40 shear. So to be able to access Profis Engineering, you may go to profisengineering.hilti.com. So you may register through your registered Hilti account. So before we start the demonstration, we will now give you an overview on what does a Profis Engineering interface looks like. So for report template, you have three types of report template for detailed, long, or short, depending on your submittals. So for short, only oh, so we have to ask again. So for report, there are three types of report. So for short, only the results shown in the calculation, no formula included. For long, there are full formulas with definition, and later we will show the detailed type of report. So for the settings and all the general parameters, so the default parameters is seen in the. So you have a discretion to change each parameters depending on your engineering judgment. So for advanced base plate design. So mesh will be calculated on this part. So you may produce a thinner mesh or greater mesh. So for interaction, so as of the moment, we have the Global, RISA footing, SAP 2000, Robot, ETABS, and STAAD Pro. So for future, we are still adding other structural softwares during our market sensing. So for anchoring concrete connections, you may select your region. So may select Philippines. So units and default parameters can be seen here. You can change any of the parameters. So for anchor calculation methods and approval, you may select either European, ACI, or other design-based standards. So I will be using ACI. So for ACI, I will be selecting the ACI 318-14. So if ACI 318-19 will be updated, so automatically, since Profis Engineering is a cloud-based software, it will be automatically uploaded into this design software. So still calculation method and parameters will be from AISC and LRFD-based design. So for Profis Anchor user, you can still use your design from Profis Anchor to Profis Engineering by using this export design tab. So you may select the software. For example, I have created a connection detail from Profis Anchor before, then it will be automatically imported to this software. So there must be at least warning for you to review the input values for anchor plate, concrete cover, and rebar size. So it will automatically import the details from your Profis Anchor to this Profis software. So now we will now go to our connection sample problem. So for our connection problem, So we will be having connection of 300 by 300, W6 by 9, 50, 40, 700, 190, 55. So for the menu tab, you can see for the favorites tab where you can input your favorites formulas or base material parameters. So base material is cracked concrete with 5,000 psi of concrete. So if the compressive strength is not here, so you can input your custom compressive strength in megapascal. So 5,000. So the concrete thickness is 700. You can change the parameters here or directly at the geometry. So for installation method, this is very critical when it comes to adhesive anchors because the core drill may reduce the surface roughness coefficient of the surface hole. So for diameter 16, we will be using hammer drilled holes. Then for hole type condition, so as per ACI, the post-installed anchoring must be at least 21 days age of concrete. So it will be considered as dry. So if the connection is less than 21 days, you can use water saturated concrete condition. So the Profis engineering can also calculate water filled holes, submerged and underwater hole. Then you can also provide a supplementary reinforcement. So for details of supplementary reinforcement, you can refer to ACI 318 Chapter 17 for details of edge, reinforcement, shear, and tension condition. Or you may actually see from this help tab. So for demo purposes, since we do not have the details of the existing rebar, so we will not put any edge reinforcement and conditions here. So for anchor plate, so the connection is ASTM A36. So the plate you can increase based on your design preferences, or you may provide your custom strength of the material property of steel. So we will be selecting the A36. So for A36, our size is 300 by 300. So the spacing between anchors is 190. 190. So you may import the parameters directly on this geometry, or you can import directly by using the 3D model. So either move this anchor based from your preferred spacing. So if you have errors with your previous work, we have the undo button. Then we can do a coordinate system. So the center of the ordinate coordinate is located at the center of the profile. So we are done with the base plate. So the thickness of the base plate is 10. So you can also take the effect of standoff in your connection, whether the standoff directly affect your shear connections, tension connections in this. So with this, we'd have no standoff effect. So for anchors, so since Hilti has multiple of products, so you can see the types of products for Hilti, whether mechanical or adhesive anchors. You can also see the approvals from this tab. So approvals, if the Hilti has the approval for seismic, specifically for HY200, uh, approval for cleaning, approval for if the connection is approved for seismic and have a variable embedment. So the connection is using RE500V3. You can change at this tab or at this location. Then the strength of rod is 8.8. So the capacity of rod is class 8.8. So 800 MPa for tensile, 640 MPa for yield. So strength diameter is M16. So you also have options to optimize the embedment length, embedment depth based on the load reactions that the anchor can resist, or you can import your variable embedment. So with this, we can also view the evaluation certificate. So each evaluation certificate provides Profis Engineering the right magnification factor or bonding stress based on the connection. So you, as your parameters, so if you will be doing manual calculation, you can check using this software. So you can check for the strength reduction factor for tension depending on the material class type. So we are done with the anchor. So next for the steel profile, we are using AASC for W-shaped anchor, W-shaped steel profile. So it's W6 by 9. So now we are going to provide the load uh, for the connection. So for the loadings, we can import from structural software or manually input the loads at the result tab, the loading tab here. So you can create your own load combinations. So this is based from IBC 2018 and IBC 2015. Or you can input your custom factor loads, same as this one. So or you can export loads from spreadsheet like Excel. So the columns and row must be same with the columns and row from the loading tab. So you can import connection loadings here or directly on the geometry. So this design load is 50 for tension, then 40 for shear. So as you can see, the software automatically computes the tension failure mode and shear failure mode for just 2 seconds after input. So you can, for tension failure mode, it will be checked for steel, concrete breakout, bond strength. For shear is steel, concrete edge breakout, and pry out. So if you want more details about how to design anchors using ACI, you can refer to the on-demand webinar at www.ask.hilti.com.sg. So this is the calculation based on a rigid base plate assumption. So what we can do now is to compare the rigid base plate to non-rigid base plate using the CBFEM method. So we will now conducting the analysis. So we will check if there is a prying force and additional force on the 10 of the anchor rods. So we can do now is calculate. So the iterations automatically depending on your software or internet connection. So as you can see, there is additional force. So at your left side will be the rigid base plate. And for this, the non-rigid base plate assumption. So there is additional tension force that acting on the rod. So you will see a deviation of almost 50%. So as designed for Hilti, we only allow at this maximum of 15%. So you can also see the plastic strain for 0.15% and concrete stress. So based from our poll earlier, we can do to resist the prying force, we can do is increase the base plate thickness or change the profile or add additional plate. So we will be conducting a increase. So we will be checking if we can increase the base plate thickness. So what will be the effect on our connection design? So the thickness of plate is increased to 25 mm. So as you can see, so the additional thickness reduced the prying out of the base plate. So we have reduced from 50 to 10 to at least 11%. So it is your discretion if you are into designing connections with 25 mm thick plate. So we have another option to provide stiffener plate. So, so since we are adding additional plate, we may reduce this to at least 16. Then for additional plate, you may go into your profile. Then as required in our sample problem, we need to utilize the the weld. So we'll be using fillet weld for both flange and web. So as at the message pane, you can see any weld throat thickness parameters. If the parameters above the minimum value or the maximum value. So the maximum value for web is 3, thickness of flange is 3.86. So we'll be using at least 3 mm thick weld, fillet weld. So for base plate, since prying acts on both major and minor axes, we will provide stiffener plate for both direction. So you have the options to provide triangular, rectangular, or chamfered stiffener plate. So in this case, we'll be using chamfered for typical detail. So the height will be at least 100. Then thickness, your discretion if 4 or 6. Then we will also utilize the weld for the stiffener plate to fillet. So the maximum is at 3.86. So we'll be using 3 mm weld. So this will be your second option, utilizing 16 mm thick base plate with additional stiffener plate. So we can calculate the connection, full connection design. So with additional stiffener plate and reducing the base plate to almost 16 to optimize the connection, we also have a at least reduced deformation. So 5 to 10%. So plastic strain reduced to at least none. So for concrete stress is 2 mm, 2 megapascal for the concrete strength. So we can now go into the confirmation to check for the utilization. So for tension and shear, we also passed the requirements. So we have also checked the stresses between the anchor plate. So it is at 64 megapascal. The maximum for the material is 248. We can also check for the stresses at the stiffener plate. So it's 76, same material, ASM 836. So we can also check for the load bearing of concrete under the base plate. So for steel profile check, the stress reflected here is only at the connection profile. It does not include the local buckling of the whole steel element length. So with this, we can now generate a sample report. So we will be generating a detailed report. So it will automatically download the report from this Profis engineering software. So from the design report, so it can be used for submittal, design calculations to submit to our customers, to our clients, and to our consultants for approval. So you can see the material type of anchorage if it is adhesive. So you can see the base parameters that we have input on the Profis engineering software. So you have the checks, anchor checks for tension. So you have the capacity check for tension. You also have the formulas for reference. So for tension and for shear. For steel with deburr arm, prying out, and concrete edge failure. So for the next part, you can see the anchor plate design. So anchor plate, this involves all the formulas used during the calculation. So you can see the base plate classification, the deviation and stresses between plate, plastic strain, and compression stress. Then you can check for the weld for each location. So for the weld, we can check for each location depending on the capacity here. So we can check the weld curves per location of the connection. So the utilization is shown at the results tab, results location. Then for the concrete bearing stress, the formula is located here based from AISC. So the full connection using Profis engineering were checked for anchors, anchor plate, welds, stiffeners, concrete, and also the profile. So the fastening meets the design criteria. So as discussed earlier, so furthermore, after we have designed the full base plate connection, we can also export the details to Tekla or other BIM or CAD software. So we can use this export tab, export via Trimble Connect, or export your 3D model. So we can export the anchor plate, profile, anchors, concrete block, welds, and stiffeners. So if you have any questions regarding integration, you can actually look at Profis Engineering or www.ask.hilti.com. So you can see the 3D model of our connection. So we can export it via 3D or via 2D. So other formats are shown here. If you are using AutoCAD, SketchUp, or any detailing software, so we'll be downloading at least a front view and at least a isometric view. So it will be automatically depending on the format. So since I'll be using AutoCAD, so I'll be using DWG software. So it will be automatically download your software. So you have a direct insert like click to CAD toolbox is also possible. So automatically downloaded the detail. So for front and isometric view. So for this isometric view, so it automatically export all the details, including the profile, stiffener plate, uh, anchors, base plate size, and concrete thickness. Then for specification text, you can look at the front elevation. So it also provides the specification for that specific connection. So you can see the anchor specification using HIT RE500 V3. So this will be the reference of the contractors or installers to be used at site. So you have also the installation procedure. What is the drilled hole size in concrete, drilled hole size in base plate, and hole cleaning method, and other base material parameters. So you can use this as your guide to, to do your detailing softwares. So now we will now going back to our presentation. So as conclusion, we have created a web interface for structural software to integrate with Profis Engineering. This will allow the user to simply select the nodes they wish to analyze and the load combinations they wish to transfer. And the loads will automatically be exported into Profis Engineering. So this eliminates the need for manual transfer or guessing the critical combination, as you know, have the ability to calculate all combinations at once to know for sure. So currently, plugins are available for global software such as SAP 2000, ETABS, Robot, STAD Pro, and Global. So, and we are always looking to grow this list. So users of other software can still take advantage of import functionality with Excel, so which allows a simple cut and paste from a common Excel datasheet or CSV file. So as mentioned, you can now design a complete connection in the single platform for a consistent and fast design. So all in roughly the same amount of time you would take to design just one of these components before. So finally, users will be able to export geometry directly into their BMM CAD software using a plugin for Tekla, and users of other detailing software can still export BIM CAD files of the design from the platform to insert into their plans and details. So overall, this will dramatically speed up the entire connection and design process for engineers. So now we know how to design anchor connections using Profis Engineering. So firstly, it depends on what you want to design. So if you just want to design the anchors and will design the base plates separately, you can carry out with the same rigid design similar to Profis anchor. But if you want to design the full fastening and your base plate must be 100% code compliant with no wiggle room, then you can design a realistic design with close to 0% deviation and proceed to design the remaining components of the connection. So if you are allowing some degree of judgment in your design, you can design up to 15% deviation, as we have just shown, and design a close to rigid base plate. So finally, if you're happy to do the base, if you're happy to base the design on your own engineering judgment, you can design a flexible base plate with greater deviations, but must be aware that you might be going beyond the scope of some parts of the anchor design codes. So I again want to highlight that Profis will produce a result for the anchor calculation regardless if your base plate is close to rigid or not. So it is important that the designers must be aware of this. So now let's take our third and final poll of the day. So the poll windows will be open, will be coming up to your screen right now. So the poll is that you find designing full anchor connection using Profis Engineering useful. So please answer if yes or no. Then we will give you some time to cast in your answers. So let's have a look at the results. So good news that a majority answered yes, but somebody have to say no, but that's good to hear. So thank you. So we hope that by now you are just as excited with the design advanced baseplate module implemented in Profis Engineering and the other new softwares and software plugins. So if you would like to find more information or want to have a live demonstration of the software at your office or through Skype meeting due to the ongoing enhanced community quarantine that we have experiencing as of the moment, you can reach out to your Hilti engineer or let us know in the survey at the end of the webinar and we can arrange someone to reach out to you. So another way to reach to us is by visiting your country's Hilti online website. So you can sign up the free demo button in the web page to request a demo of the software. So we will be also be sharing this link with you after the session today. So are you ready to get the Profis Engineering? So register today at profisengineering.hilti.com. So before we wrap up, we now invite you to submit your questions in the question box and we'll respond in a while. So I will now pass it back to Joni with the discussion on our digital approach, the Ask Hilti channel.
Thank you, Richmond, for a very meaningful live demo and concise discussion of Profis Engineering and how it can help our fellow engineers in their anchor connection design. Now, before we end today, we would like to inform you that Hilti Asia Pacific has launched the Ask Hilti website for Southeast Asia. Now, the technical colleagues from Singapore, Thailand, Vietnam, Indonesia, and Philippines, of course, can now register and start using this platform. So what can you get from Ask Hilti? Now, with Ask Hilti, you now have a platform that can provide you expert advice in the form of question and answer forum under the Ask section of the website. Now, there is also a continuing education through live webinars, similar to what we are doing right now. An on-demand version, however, is also available. So basically, these are the recordings of our past webinar where you can have access 24/7. Now, lastly, we also have published articles that our Hilti experts have written in articles in Anchor, Firestop, Seismic, and many more. All of these again in one platform, which is the askhilti.com.sg. So once again, I am Joni A. Cruz and I turn you over to Engineer Richmond Olaya to answer some of your posted questions.
So now we'll be offering the floor for some questions and that is raised during the session. So we will be spending a couple of minutes to address them. So you can now type your questions in the question box. So I've seen some questions regarding process engineering today. So this based from our customers. So how do I access process engineering today? So what are the three licenses type? So good question. So thank you. So being a cloud-based software, to request and access to process engineering, you will need to purchase a subscription from us. So we can go to our Hilti website, which is hilti.com.ph and register depending on your account. So you go to engineering, then go to Profis Engineering Suite. So with this, you can sign up for free demo. Uh, Look for the benefits. As we have discussed earlier, the game-changing features, calculation, and for the licensing type. So we have a standalone single user license. So a one user per account can access the Profis Engineering at the time. So per year, the basis, so 14,500 per year. For floating license or what we call multi-user license, it's up to 30 users per account or per company. So only one user access at the time per license. So it's 18,500 per year. So your IT department can transfer each account to all registered users. So for last is the enterprise license. So best for large companies. Normally we have a minimum of 30 users. So share licenses with anyone within the same company. So however, the price is available on request, so you can request a code. So if you are applying for a subscription today, so you can do apply now, then go a customer account application form. So this is regarding your business, company name, purchase account, so what type of license you are into, and just agree. So or one of our engineers, or if you are interested, so you can contact one of our engineers to address your concerns. So we may can at least able to do some questions. So the question from specifier at the north. So are any limitations to your Profis Engineering software? So at least good questions. So for the limitations, we can look for the Profis Engineering. So please do take note that all designs are based on ICC ESR approval. As discussed earlier, all the bond stress, all the magnification factor, strength reduction factor is based from this evaluation report. So all designs per ICC ESR for a product can be designed to our software. So for analysis outside evaluation report, Profis would not be appropriate to handle those designs. So we can now at least run for a one question because we are 3 minutes ahead of our time. So for our last question, so based from the software, we have options to input design load and sustain load. So which failure mode does the sustain load be critical? Sustain loading. So here. So you can input the sustain loadings at this blue tab of the load reaction. So for adhesive anchors, this sustain loads is typically for adhesive anchors only. So for adhesive anchors, sustain load can be used if anchors are constantly in tension. So to mainly check the capacity of an adhesive anchor throughout the anchor service life. So the software will be then perform a sustained loading check by multiplying the values of concrete breakout to a magnification factor of 0.55. So for example, so we will be checking our connection if the connection can be able to resist the sustained loads of 50. Then calculate. So the factor 0.55 was correlated from, I believe, ACI 355.4 for adhesive anchor test requirement. So it automatically check for the sustained loadings throughout the service life of the anchor. So hope that question answers your this question. So for questions not answered during the session due to time constraints, we will reach out to you through email or one of our engineers will reach out to you to answer your questions, or you may use your digital channel to drop in your questions at www.ask.hilti.com.sg, and we will revert back to you. So that brings us to the end of the presentation today. We hope you found the presentation informative, and on behalf of Hilti, thank you for the attendance today, and we look forward in welcoming you to our upcoming webinars. So we will be conducting a webinar next week for non-structural trade. So thank you and enjoy the rest of the day.